Okay, we're going to take a look at the difference between relations and functions. Actually, all functions are relations, but not all relations are functions. So the tricky thing is that relations have a set of xy values. They have an equation sometimes. They have a domain and range. They have graphs. But there's one thing that distinguishes between the relation and the function. And this is it. For each x value in a function, or the input, there is only one corresponding y value. So let me give you an example. If you were looking at an input-output chart, and let's do 2. So the first input-output chart, it says you put in a 2, you get a 4. Put in a 2, you get a 5. Put in a 2, you get a 6. This is not a function. If you put in a 2 in a function, you must always get out the same value. Over here, let's say you put in a 3, you get out a 9. You put in a 4, you get out a 9. You put in a 5, you get out a 9. This is a function. In this case, 3 is matched with 9, and that's okay because it's only matched with 9. 4 is also matched with 9, which is fine. It can always be matched with 9. And 5 is matched with 9. It's okay, as long as I'm not changing what I get out when I put in the 5. So I can't say put in a 5, get out a 9, put in a 5 again, get out an 8. Always has to have only one corresponding value. So that's what it might look at as a table. And on graphs, we have what's called the vertical line test. So we can check for function. A function with the vertical line test. Here's how it looks. We take our graph. Let's say we have this graph here. And we draw vertical lines anywhere we want. So here it could be here. And I mean, if we could input an infinite number of vertical lines, it'd be even greater. So at each vertical line, and obviously the vertical line goes through an x value, there's only one corresponding y value. So yes, this is a function. But let's say we have another graph. This have a little more room here. And this other graph looks like this. And as I put in some vertical lines, you'll see that it passes through 2 points. This is not a function. Okay, so we can use that to test whether we have a function or just a relation. So let's take a look at some examples. Number 1 says, determine if the graph is a function or just a relation. Explain how you know. So we can use our vertical line test. And I can see pretty much just by looking at this that anywhere I would put a vertical line, I'd only have one point going through. So this is a function. If I look at number 2 though, I can put a vertical line here, I can put a vertical line here, and there's many points where if I were to put a vertical line, I'd have two y values, two output values. So this is just a relation. Number 3, we're going to graph it first, and then determine if it's a function or a relation. So I need a table of x, y values. I'm actually going to transform this because I can't really get rid of that absolute values, but I can have my equation as absolute value of y minus 2 equals x. And I'm actually going to start with my y value and get out my x value. So I kind of got to flip it around, still keeping the x and y the same though. So x, if I put, or let's try y. If I put in a 0, I get out a negative 2 for x. If I put in a 1, get out of a negative 1. Put in a 2, I get out a 0. If I put in a 3, I get out a 1. It looks like I'm going to continue with this pattern, so I'm going to actually go below 0, put in a negative 1. If I put in a negative 1, I actually get out a negative 1. If I put in a negative 2, get out a 0. Put in a negative 3, get out a positive 1. So I can kind of see that this is kind of going to come back around on itself because I have some values that are kind of repeating. So let's graph this. Negative 2, 0. Negative 1 up 1. 0 up 2. 1 up 3. Negative 1 down 1. 0 down 2. 1 down negative 3. Oh, I see I have a, looks like a absolute value on its side. Well, just looking at this, if I were to put in a vertical line anywhere, I'm going to cross at 2 points. So this is a relation, not a function. And I can even look at my table of values. Notice how if I inputted for the x, a negative 1, I got out a 1 here. But when I inputted in for the x here, I got out a negative 1 for the y. So this can't work. This is a problem because we cannot change our output value for the input. We cannot have different outputs for the same input. Okay, number 2. I'm going to solve for y here. I'll just divide by 2. So I got y equals x plus absolute value of x all over 2. So let me make an input-output table here. So our answers don't get lost, actually, while I'm thinking about it. Okay. Now we have pick some x's. So let's just start, we'll start at 0 in the middle. Sometimes that helps me go both ways. Put in 0, I get out 0. Put in positive 1, I get out 1. It's 1 plus 1 divided by 2. Put in 2, so 2 plus 2, 4 divided by 2 is 2. Put in 3, 3 plus 3, 6 divided by 2 is 4. Let's try some negatives here. Negative 1 plus, this becomes positive 1. So that gives me a 0 as well. Negative 2 plus positive 2. Interesting, gives me a 0 as well. Negative 3 plus positive 3. This is an interesting graph. So let's try to graph it and see what's going on here. At negative 3, I'm at 0. At negative 2, I'm at 0. Negative 1, I'm at 0. At 0, I'm at 0. At 1, I go up 1. At 2, I go up 1. So follow that path. And so I have what we would actually call, what kind of looks like a piecewise function. So 2 specific parts. The one part is just a horizontal line. The other one looks like a linear line. And so I'm looking at this, and I'm okay to have the same output as long as it's for different x inputs. That's okay. And you can see if I do the vertical line test, I'm only crossing one point there. So this is a function.